Is that okay? You can see the screen?
Yes,
Yes,
madam.
madam.
Okay, great. So we will start off from where is it? Okay, exercises, yeah. Okay, so this is the part madam asked you to do and submit in the Google Classroom. So far, all of you, most of you have already submitted, with some haven't submitted, and I don't know why lah. So those who haven't submit, you do your correction, and then afterward, resubmit. Now, so I will see who is submitting late over there. Okay. Over here, madam want to highlight a few points. Make sure on the Lewis structure here, you all show your calculation. So madam can see if you draw the wrong structures, then madam will see where did you get wrong. Is it the total value is wrong, or the structures, the number of valence electron is wrong? Okay. And then over the electron group, this one most of you didn't. Some of you lah, about 40% of you didn't do it. When you write two electron groups, please also show what is the combination. Is it two bonding pair, three bonding pair, two bonding pair, one lone pair? You need to show the combination. Okay, so the short form madam put inside the table like BP represent bonding pair, LP represent lone pair. Okay. And then for our electron groups over here, remember electron group somehow is the similar as our basic shape or basic geometry, and there's only 5. Okay, 2 electron group linear, 3 electron group trigonal planar. But then it will be different from our molecular shape. Okay, so those who got wrong over here, please do some correction. Now you can use your red pen and then jot down on the place where you get wrong. General formula AX or AXE, you're using the symbol. Okay, so when you look at the molecular part, molecular geometry and also bond angle, please draw it following the shape, and also you need to put down the name of it. Linear, trigonal planar, is it V shape? What else we got? Trigonal pyramidal, tetrahedral. Okay, you need to put down the shape. Besides drawing it, you need to put down the name as well. Okay, some of you did it, some of you didn't. So madam remind here over again. So make sure you put down the name of it, and then showing the shape inside your Lewis Lewis structure. So for example, if we take the structure of SO2, okay, so again SO2, because sulfur, it can be octet or it can be expanded. In this case, some of you may wonder, madam, why you say that SO2 following the former charge, SO2 with 2 double bond is more stable? Okay, but you remember over here, your SO2, the sulfur, will achieve the octet first. Then only you can expand it. You remember this one? So both of it we will accept, because sulfur, it can be octet as well as expanded, but not necessarily expanded, because I have already got enough octet, you see. But for incomplete, we will achieve incomplete first before we reaching the octet. So for BE, B, and also AL, the bubble, that one is compulsory or definitely incomplete. So other than that, we will see. If got choices, octet or expanded, we go for octet. Why madam will show it in 4.3. So when we want to do hybridization, that part comes in the priority. Okay, so please remember also in your structure, so this one is correction for those who got wrong. Your molecular geometry, the Lewis structure, the lone pair over here, you also need to put down lone pair or the octet for the surrounding atom. Unless you got hydrogen, then hydrogen don't have lah. Hydrogen only duplet. But somehow you see over here for fluorine, for chlorine, they all need to be octet. So the surrounding lone pair you need to put in. So ada yang salah dekat sini, sila buat pembetulan . Okay. So untuk dekat sini ada soalan ke nak tanya madam? Do you have any question? Tak ada . So make sure tuliskan nama dia, nama untuk shape. Bond angle terus catat atas structure boleh, awak nak tulis tepi pun boleh. Tak nak label dekat sini. Contoh, dekat sini less than 120, you want to write beside it. No problem, can also. Just to make sure you are clear lah, where is the bond angle. It should be between two bonding pair. Okay, so including the shape over here, so you will see, oh, this one is V shape, where you have my combination two bonding pair with one lone pair for SO2. Okay, whereas for 4 electron groups, you can check your answer over here. We have tetrahedral for CCl4. Okay, bond angle 109.5 degree. And then for NH3, okay, this one, right? Specific for NH3 and also H2O, bond angle, they have the specific value. Okay, both of it is less than 109.5. Okay, but for NH3, they have got a specific bond angle 107.3. So value ini awak kena ingat, setiap kali awak nampak saja NH3, bond angle dia mesti 107.3. Kalau awak nampak H2O, dia mesti 104.5. Kalau untuk structure lain, awak boleh tulis range dia saja, less than 109.5. Is that okay?
Okay, madam.
So dekat sini catatkan atas awak punya exercise untuk bond angle NH3 107.3, untuk H2O 104.5. Okay, and then jot down also the name of the shape. We got tetrahedral, we got trigonal pyramidal, and we got the V shape. So either you write V shape or you want to write band, also can. Okay, so for V shape and also band shape, there is two. So if you can look through the 3 electron groups over here, and also 4 electron groups over here, it's just differ by the combination. You see, for H2O, 2 bonding pair, 2 lone pair give you V shape. For SO2, there is 2 bonding pair, 1 lone pair, also giving you V shape. So you need to see what is the electron group and also what is the electron group arrangement. So they fall into different category. Of course, there is some others example lah. Cuma example yang madam bagi dekat sini adalah salah satu example sahaja. Ada banyak lagi molekul yang kita boleh pakai. So dekat sini hanya example sajalah. Okay, ada soalan ke untuk 4 electron groups? Any questions?
No, madam.
Okay, so for our last session, we also talk about 5 electron group, isn't it? There is 4 shape. We got trigonal pyramidal. Trigonal bipyramidal. Bi means you got up and down. Pyramid on the outside, on the above, and then pyramid on the bottom. Okay, and then we have seesaw shape, we have T shape, and also we have linear. Okay, so over here also, madam show you the example for where is it? Okay, exercise. One of the example which include the charges. So say in the table also, some of you submitted together, which is well done. Okay, but no worry, you can later on complete your table for 5 electron group and also 6 electron group. Okay, so over here, madam show you one example with charges, which is IF4 positive. Okay, iodine tetrafluoride. Okay, so over here, you're still using the same method when we are drawing the Lewis structure. 1 fluorine, 7 valence electron, 1 iodine 7, and then 4 fluorine berapa? Ini recap sikit
28.
28. Positive charge?
Negative.
-1. Don't forget about your charges, very important. Okay, so over here, overall, how many do we have? 30?
34.
34. Okay, so central ion is your iodine because iodine is less electronegative. And then surrounding it, we have 4 more fluorine. Remember, fluorine, we need to complete with the octet. Okay, so combining step 3 and step 4, we completed all the electrons surrounded first. Okay, so now for fluorine atom, each with 8 electron, and here we got 32. Okay, so 34 is your total. After minus 32, how many left? Okay, how many electrons left after I subtracting all the electrons in the structures here?
2.
Tinggal lagi 2. Berapa lone pair kalau saya ada 2 elektron?
1.
1 sahaja ya. 1 lone pair dekat sini sahaja. Okay. So electron groups, because it's fall into category 5, we have 5 electron groups. How about the combination?
4 bonding pair, 1
4
lone pair.
bonding pair, 1 lone pair. Okay. How about the electron group arrangement?
Trigonal Bipyramidal.
Okay, Trigonal Bipyramidal. Sorry, yeah, you can hear my sounds clear or is very noisy. Is it okay for Madam Sam?
Clear, madam.
Can.
Clear boleh dengar Madam.
Boleh, madam.
Sebab Madam punya kipas dia bising sikit. Okay, so general formula dekat sini, electron group arrangement sama untuk semua sebab kategori sama. So general formula dekat sini kita ada 4 bonding pair, so AX4 and then with 1 lone pair. So when you want to draw the molecular geometry, we're following the shape. So remember when we have 4 bonding pair, 1 lone pair, what will be the shape? Sorry, any lone pair, yeah. Okay, what will be the shape?
Seesaw.
Seesaw. So ikut kumpulan yang kita ada dekat table. Okay, so when we have 5 electron groups, so center will be I. Okay, untuk sesiapa yang guna AX, AX adalah untuk general. Tapi sekarang awak sudah ada formula sendiri, IF4 positive. So guna formula yang sedia ada. Jangan pakai AX lagi. Okay, so I, F, 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 F. And then in your molecular geometry also, you need to show the surrounding atom with the octet electrons. Okay, and then extra 1 lone pair onto the central iodine. And don't forget, there's a positive charge overall. So for both of your Lewis structure and your molecular geometry, you need to show the charge. So dekat sini awak boleh practice lah formula charge. Untuk iodine berapa, untuk fluorine berapa. Boleh nampak lah siapa yang pegang positive charge, siapa yang pegang negative charge ataupun zero. Okay. So when you have done already over here, then you need to write down the name of the shape, which is seesaw. And you will have a bond angle of less than 120 and less than 90 degree. Okay, for seesaw shape, it will be very difficult for you to label the bond angle, right? No problem, you write beside it. Asalkan nampak nombor itu, then that's okay. So untuk seesaw shape, Madam suggest awak tulis bond angle dekat tepi dia. Okay. Ada soalan ke dekat sini? Is there any question for IF4 positive? Ada soalan nak tanya? Okay, kalau tak ada kan nanti.
No, madam.
Okay, kalau tak ada nanti awak completekan untuk part yang dekat sini. So last lesson also we left with one electron group, which is 6 electron groups over here. So we just complete it. Now you got the idea already. It should be very simple. Okay, so if you remember what Madam said, when you have 2 electron groups, you got 1 shape. 3 electron group, there is 2 possible shape. Okay, depends on what is the combination. And then for 4 electron groups, you got 3 shape. 5 electron group, you got 4 shape. And then when you come into 6 electron group, it should be having 5 shape, but you only learn 3 shape. Nah, so dekat sini 6 electron group kategori awak hanya belajar 3 shape saja. Octahedral, square pyramidal, and also square planar. So ini nama Madam sudah bagi. Bukan maksud tak payah tulis, kena tulis juga kalau awak lukiskan structure tersebut, ya. Okay. So if we got only 6 bonding pair, so the general formula AX6 molecular geometry exactly the same. So we have A, top we have 1, 2, 1 and 2, and then at the sideway each of them holding 2 bonding pair. So surrounding atom ada 6. So untuk 5 and 6 electron group, they are all expanded octet. Sebab kalau awak tengok fokus kat central atom A, you have already 12 electrons. So obviously, it is expanded. Okay. Lepas tu nanti kita tengok example lah. So bond angle dekat sini adalah 90 darjah sahaja. Okay, so only one bond angle, which is 90 for octahedral. Okay, and then we have the combinations, 5 bonding pair, 1 lone pair. The general formula AX5E. So it will show like a square pyramidal. Okay, so kalau awak rujuk kepada octahedral shape, salah satu X kita gantikan dengan lone pair. So over here we have some shape like this. Only 5 surrounding atom with 1 lone pair. So ingat untuk molecular shape, kita hanya tengok pada bonding pair sahaja. Okay, hanya tengok pada bonding pair saja. Kalau electron group arrangement ataupun basic shape, kita ambil kira bonding pair dengan lone pair kedua-dua. So kalau dekat sini awak tengok square pyramidal, why we say square pyramidal? At the bottom you have one square, and then on the top over here you have one more atoms, right? So the one that Madam drawing over here, yeah. So it look like a pyramid with a bottom. The base is a square. So we call it a square pyramidal. So boleh nampak kan dekat sini nampak satu pyramid. Dengan base dia adalah square. So we call it, we name it as square pyramidal. Okay. Kalau untuk square planar pula, combination dia adalah 4 bonding pair, okay, with 2 lone pair. So general formula AX4E2. So remember our Vesper theory, we want to locate the electron pair as far as possible. So in this case, kita tak akan letak dia tepi-tepi. Kita akan letak atas bawah. Sebab ada pilihan. So you choose to locate both of the lone pair as far as possible. So one lone pair on the top, one lone pair at the bottom. To keep them far apart. Okay. So dekat sini boleh nampak lah. Ya. Yeah? Kenapa ya?
So for the lone pair, we can actually put it on the side also, as long as it is on the opposite sides.
In the opposite side, because you follow Vesper, we want to put your electron pair as far as possible. Kalau let's say lah Madam tunjuk ini contoh yang salah. Kalau sekarang kita sudah tahu structure dia macam ni, lepas tu bond angle semua sama 90 darjah. Kalau awak letak tepi, dia repulsion dia sangat kuat. So, dia tak suka, tak happy. So, tak boleh. Okay. Kalau untuk 5 electron group, kita ada 2 bond angle. So, lain cerita dia. Untuk octahedral, 6 electron group, you only got 1 bond angle, 90 degree. So, you have to locate them up and down. That is the ideal position. Okay, so if you look at the square planar over here, so imagine now, just now, Madam using this one. This surrounding atom is missing. It's gone. So replaced by a lone pair. So now you only see a square planar. Okay, you only see a square planar over here with 1, 2, 3, 4 surrounding atom. Center one is your what's called central atom. Okay, so over here, your square pyramidal, you have less than 90 degrees Celsius, 90 degree, less than 90 because of the repulsion. Repulsion antara awak punya lone pair dengan bonding pair dia sangat kuat, dia akan push dia ke atas. So bond angle sekarang dia kurang daripada 90. Okey. Tapi kalau untuk square planar, atas push ke bawah, bawah push ke atas. So dia nampak macam satu square planar. You can see my drawing right. Dia satu square planar. Kat atas sini Madam lukis guna ni ada lone pair, kat bawah ada lone pair. Okay. So dia punya repulsion, dia push ke atas push kat bawah. So maksudnya dia punya bond angle tetap 90. Oh, can you see my screen over here? So there's no need to write less than 90 for square planar. Square planar memang 90 darjah. Ngap-ngap. Is everyone good?
Okay, madam. Good.
Okay.
Alright, madam. Noted.
Alright. So the last one over here is to make a conclusion that you need to, which one you need to refer to, bonding pair, lone pair, or so on. So electron group arrangement of the basic shape, we consider all bonding pair and lone pair, all electron groups. Okay, whereas when you want to look at molecular shape, you only consider your bonding pair. Okay, bonding pair using Vesper theory and also include bond angle. So using Vesper theory is like square planar just now, where you want to locate a lone pair. Remember, as far as possible. Okay, so this is the summary for our molecular shape in general. Okay, so exercises for 6 electron groups over here also, please complete it. Similar like how you did for 2 electron group, 3 electron group, and also 4 electron group. Okay. So yang ini Madam tak minta untuk awak hantar tapi tolong completekan awak punya table. Okay, ada soalan untuk molecular shape? Is there any question for this part, molecular shape?
No,
I
madam.
don't think so as for now.
No, yeah, okay. If no questions, so last week Madam has suggested a video for you. Ayo, kenapa paste ke sini? Okay, this video later Madam will share the link. After we finish the 6 electron groups, then you can watch the video, or you watch it already, then no problem. So that one is to help you to further understand what are you doing. Okay. So our next subtopic, still under 4.2, is about polarity. Make sure you understand and know how to do Lewis structure, molecular shape, then only you can apply polarity. Kalau Lewis structure salah, molecular shape salah, polarity dia tentu akan salah. Dia depends kepada awal-awal punya. Okay, so let's just do this. Okay, so in subtopic polarity, there's 2 types of polarity. Okay, it is the bond polarity and also molecular polarity. So following the name itself, you understand bond polarity means that the polarity between 2 atoms. Okay, a single bond, what is the polarity? Is it polar or non-polar? Okay, so bond polarity is between 2 atoms. If I say molecular polarity, that means all the polar bond, all the bond polarity inside molecule. So maybe inside the molecule we have 6 atoms. Then you need to figure all the bond polarity first. So for example, yeah, in molecular polarity maksudnya dalam molekul. Bond polarity maksudnya antara 2 atom sahaja. Maybe dalam molekul dia ada banyak atom. So awak kena faham lah bond polarity maksud apa, molecular polarity maksud dia apa. Okay. So first of all, very simple, bond polarity is when you have 2 of these atoms with different electronegativity. So I'm using a shortcut over here lah, difference En, differences in electronegativity. Okay, if there is differences, then that means this will be a non-polar bond. In other words, if the electronegativity is the same for both atoms, therefore it will be a non-polar bond. Okay, so you can jot down over here, same En, okay, refer to non-polar bond. Non-polar bond. Nah, kalau En dia berbeza, baru dia akan jadi polar bond. So we have a general idea over here. The bigger the differences electronegativity, the bond will becoming more polar. Greater the differences, greater the polarity. Smaller the differences, smaller the polarity. No differences, then no polar. Okay. And then every time you need to know how to use this polar arrow. Yang ini penting, polar arrow. Ada satu, you got the tail, you got the head. This one is what we call the tail. This one is what we call the head. Okay, so how are we going to use this polar arrow? So we look at the examples of over here. CCl. We have carbon and also chlorine. And we know that chlorine is more electronegative compared to our carbon. Okay, so your polar bond is facing towards the more electronegative chlorine. So awak akan nampak dekat arrow sini, dia points towards siapa? Points toward chlorine. So when you have this polar arrow, bila awak dapat lukis arrow ini, maka dia adalah polar bond. Okay, or when you can write the delta positive, delta negative, then it will be a polar bond. So now if you compare another structure as CF, we know that fluorine is much more electronegative compared to Cl. So dekat sini awak akan nampak, ini negatif, much more negative compared to Cl. Okay, so dekat sini madam highlightkan compare dua benda ni. So you can see the polar arrow is much more bigger. Sebab sekarang ini delta En between carbon and also your fluorine is much bigger compared to between CCl bond. So kalau awak nak compare antara CCl dengan CF, CF is more polar bond. The polar bond is more polar. Tapi dua-dua adalah polar bond. So any question for CCl and also CF bond? Ada soalan? Can you get the idea about the bond polarity? Okay, kalau tak ada, madam tunjukkan macam mana kita nak tahu non-polar bond pula ya. Okay, so you look at the bottom one, CC bond, carbon-carbon bond. So carbon-carbon atom yang sama, obviously no difference in En. So dia adalah non-polar bond. Same to bromine, Br2, non-polar as well. So whenever you see something like this, N2O2H2, what else we have? F2Cl2, Br2I2. Okay, semua ini kalau dia antara dua atom yang sama, dia adalah non-polar. So over here, are all non-polar bond. Okay. Lepas tu untuk carbon dengan hydrogen, bila awak nampak dalam molekul itu hanya carbon dengan hydrogen, because the differences in electronegativity is very, very, very small. Therefore, we will consider the bond polarity between carbon and also hydrogen also non-polar. So yang ini awak kena highlightkan Walaupun dia antara dua molekul yang berbeza, tapi kalau awak nampak carbon dengan hydrogen, dia memang non-polar. So kalau non-polar, tengok atas dia, kita tak tulis pun, tak lukis pun polar arrow. Is that okay?
Okay.
Catat ya, untuk CH bond is a non-polar bond. So let's look at the bottom one. We look at the green box first over here. Dipole moment with a symbol mu. Yang ini madam call it mu. So bila awak dengar mu, that means it's this symbol ya. Mu. Something like this. Okay, so dipole moment is actually your bond polar. Bila awak dapat lukis polar arrow, that means you have this dipole moment. It's a measure of polarity of a chemical bond between two atoms in a molecule. So this is the definition. So every bond, if you have difference in electronegativity, you should have the dipole moment. Senang nak kata, ada polar arrow, ada dipole moment. Okay. Ataupun kalau polar bond, dia mesti ada dipole moment lah. And then when you have dipole moment in a molecule, because there is more than one dipole moment, more than one polar bond or non-polar bond, you will have the resultant dipole moment. So resultant dekat sini maksudnya total dia, net dipole moment dia macam mana. So dipole moment, resultant dipole moment is the total or the sum. So determine the molecular polarity. So when you want to determine the polarity for a molecule, you must know the resultant. What is the total? Okay, and this resultant dipole moment or the molecular polarity depends on your molecular shape. Awak kena tahu kan shape dia macam mana. Okay, lepas tu kena tahulah semua bond polarity. Sama ada polar bond ke non-polar bond. Okay, so the two key over here, normally in the explanation, you need to show this thing. When you have mu equal to 0, okay, yang ini mu yang tulis dekat sini adalah resultant kalau untuk satu molekul. So mu equals to 0, maksudnya resultant dipole moment equals to 0. Therefore, this molecule will be polar. If your mu or the resultant dipole moment is not equals to 0, that means it got values. Therefore, it will be a non-polar. Dekat sini salah. Sekejap ya. Terbalik dua-dua ni. This one should be a non-polar. Sorry, madam baru realise Kalau dia tak sama dengan kosong, maksudnya dia ada value. Bila ada value, dia adalah polar. Okay, please make a correction over here. Sama dengan kosong, dia non-polar. Kalau bukan kosong, maksudnya ada value, dia adalah polar. Okay, so make a corrections over here. Okay. Dah semua betul kan? Dah betul kah belum?
Dah.
Yang ini sangat penting dekat sini. Pastikan awak semua buat correction. Mu equals to 0, non-polar. Mu not equal to 0 is a polar molecule. Okay, so look at the examples over here when we talk about bond polarity. Okay, we got I2. So between two similar atoms, the electronegativity differences is 0. Okay, therefore the resultant dipole moment will be 0. Okay, when mu equals to 0, it is a non-polar molecule. Whereas when you have ICl, iodine and chlorine, they have differences in electronegativity. Dan kita kena lukis polar arrow ini. Siapa lagi elektronegatif, kepala dia hadap ke siapa. So in this case, chlorine is more electronegative, then the arrow will pointing towards the chlorine. So the resultant dipole moment will not equals to 0. So dia punya net dipole moment, dia ada direction. Dia hadap ke satu arah saja. So maksudnya dekat sini memang ada value. Kalau ada value, dia bukan kosong lah. So if the mu is not equals to 0, it will be a polar molecule. So in this case, ICl and also I2, the bond polarity is similar to molecule polarity. Sebab dalam structure ini hanya ada satu bond, so kita panggil dia sebagai bond polarity. Dalam structure ini sama juga macam ini adalah molekul dia. Ini adalah molekul. So kalau kita nak cakap molecular polarity, dia punya jawapan pun sama juga. Molecular polarity is the same as bond polarity because inside the molecule, you have only one bond. Any question for this one?
No.
Okay, tak ada soalan, kan kita teruskan kepada molecular polarity. Okay, so bond polarity between two atoms, molecular polarity, you have to look at the overall structure. Okay, so the overall polarity depends on the combined effect of the individual polar bond or non-polar bond. Okay, so it depends on your molecular shape. Okay, and then you need to know all the bond polarity. You need to know the resultant dipole moment, whether it's equal to 0 or not is not 0. Okay, and then the last one very important because it's I think some of you didn't know about the meaning, or maybe you know about the meaning. Symmetrical or asymmetrical. Is it look like the mirror image, or it is not the mirror image like that? So boleh search lah what's the meaning of symmetrical, what's the meaning of asymmetrical. Okay, and madam will show you the example lah, which one is symmetrical, which one is non-symmetrical on the bottom example here. Okay, so we fill it together. CO2. Okay, carbon dioxide. So the structures of your CO2, this one also you need to start with the Lewis structure, calculating total valence electron, then what will be the structure? Okay, so let's say lah, we take the structure of carbon dioxide with two double bond on the center carbon. So the bond polarity, yes, CO, there's a differences in En. Therefore, these CO bonds are a polar bond. So remember, when you have a polar bond, when you have difference in electronegativity, dia mesti akan ada polar arrow. So dekat sini atas saja kita lukis lah. Jangan lukis dekat bond So you just draw another arrow on top of the bonding. Towards the left, towards the right. Okay, so for this shape, it is symmetrical. So when you look at the shape over here, you can see, oh, it looks like a mirror. On the left, on the right, is the same shape. Okay, so therefore this shape is symmetrical. Maksudnya dia sama lah kiri kanan dia. So over here, you can see the dipole moment because they are the same, therefore they can cancel out each other. Dia boleh potong. Kiri boleh potong dengan kanan. Cuma awak tak payah tunjuk, awak jelaskan saja. Explain only. You don't have to rub off that arrow. You have to show the arrow. Okay, so they can cancel out each other. Therefore, the resultant dipole mu is equals to 0. Therefore, we can conclude that CO2, your carbon dioxide, is a non-polar molecule. Okay. Is there any question for CO2? Ada soalan?
Medium.
Tak ada, ya. Okay, so the next example, we have the OCS or CSO or COS. So the structure is looking this way. One of the oxygen is substituted with sulfur, which is less electronegative than oxygen. Okay, so dia punya perbezaan electronegativity berbezalah antara CO dengan CS. So the difference is showing by how big is your polar arrow. Because oxygen is more electronegative than sulfur, then the polar arrow is much more bigger or much more longer. Okay, comparing to CS bond. Less polar. Okay, shorter polar arrow. But both of these bonds are polar. Okay, both of these bonds are polar. Okay, but which bond is more polar than the other? CS bond more polar or CO bond more polar?
CO.
CO.
CO bond is more polar than CS bond. Because oxygen is more electronegative than sulfur. So can the dipole moment cancel out each other?
Cannot.
Cannot, right? Okay, so the dipole moment do not cancel out each other. Okay, do not cancel because they are asymmetrical. Dekat sini boleh letak asymmetrical sebab kalau awak tengok mirror image dia tak sama. Walaupun dua-dua kiri kanan ada bonding tapi dia punya bond polar dia berbeza. Walaupun dia punya shape sama. So dekat sini kita hanya comparekan electronegativity. You can also write down over here lah, asymmetrical. Okay. So the resultant dipole moment in this case is not equals to 0. Therefore, the OCS is polar or non-polar?
Polar.
Polar. Okay. Mana nampak juga dalam exercise ada yang sudah buatlah awak punya last column. Tapi ada salah jugalah, nanti awak betulkan ya. So the molecular polarity depends on the overall different aspect lah you have to compare. Okay, so next one we got H2O, the molecule of water. Okay, so there's two lone pair, there's OH bond. So oxygen is more electronegative than hydrogen, obviously. So your polar arrow is pointing towards the oxygen. So nampak kan dua arrow dekat sini, dia pointing kepada oxygen. So now if you imagine this is a V shape, isn't it? So kalau polar arrow dia tolak ke atas, maksud dia punya net dipole moment ataupun resultant dipole moment hadap ke atas. So imagine both of it pushing the same direction and you will have a resultant dipole moment going upwards. Dia ada direction, dia tak ada cancel off. Okay, so we fill in the blanks together. OH bonds are polar bond. The shape is?
V shape.
The shape over here means
Symmetrical.
symmetrical or asymmetrical?
Symmetrical.
Okay. Kalau kita rujuk macam ni, kita buat mirror straight kan? Oh, nampak symmetrical. Tapi kalau madam buat mirror, dia melintang. Kalau madam buat macam ni
Macam tak.
mirror
you need
image
to
dia macam ni.
consider from the X and Y axis.
From all direction, yes. Not only X and Y. Madam pusing macam mana pun dia tak sama. Kalau kita ambil contoh CO2, I put it here. Okay, so you need to consider both of it. So dekat sini boleh catatkan dia sebenarnya adalah asymmetrical untuk H2O. Okay, so we write down over here and then nanti awak highlightkan jugalah asymmetrical for H2O. Okay. And then can the dipole moment cancel out? Maksudnya cancel out. Kalau dia kiri kanan same direction, you are learning physics, I think this one should be easier for you. Okay, if looking at the side way, if I have an arrow like this, okay, left and right I can cancel off. Kalau atas bawah, saya boleh cancel off. Kalau dekat sini, dia punya direction ke slanting a little bit I can cancel off I have the opposite side with the same strength. Then I can cancel off. But this one, H2O, they are pointing the same direction. Therefore, they cannot cancel out. Unless saya punya arrow adalah macam ni. Hadap ke direction yang opposite. Tapi dia macam heads on. So kalau macam ini, kita boleh cancel off. Cuma sekarang H2O pushing on the same direction, we cannot cancel out. So for this one, you have to fill in, do not cancel out each other. Okay, dia kena, how to say same. When you're learning vector, do you learn about vector in physics?
Yes.
The direction, the magnitude, and so on. So this one is kind of similar lah. Awak kena tengok cancel ataupun tidak, kena tengok dia punya direction. Kalau macam ni kita push ke atas, maksudnya dia punya resultant hadap ke salah satu direction. Jadi dia tak cancel off. Okay, so the resultant dipole moment in this case is not equals to 0. Therefore, H2O is a polar molecule. Okay. Boleh ke? Madam continue?
Boleh.
Okay, macam serabut Madam padamkan Okay, for your next example is XEF4. Okay, so XEF4, you have the Lewis structure, including the shape, look like a square planar. Because there is 2 lone pair, there's 4 bonding pair. So this one is a square planar, yeah? Okay, so looking at this shape, we know that XEF bond are polar. Because at Xe is come from your group 80, and then fluorine is the most electronegative atom, therefore it is polar bond. Okay, so the shape, is it symmetrical or asymmetrical?
Symmetrical.
Symmetrical.
Atas, bawah, kiri, kanan nampak kan? Okay, so yang ini adalah symmetrical. Dipole moment macam mana nak lukis? Dekat sini tak show contoh kan? So awak kena lukis. So madam guna red color ya. So fluorine is more electronegative, so pointing towards fluorine. Towards fluorine, towards fluorine, towards fluorine. So awak ada 4 polar arrow. Okay. And then how they cancel out each other? This one cancel with this one. This one cancel with this one. So there must be opposite side with the same direction. But opposite side lah. Opposite direction but same line. Something like that. Boleh imagine kan apa yang madam trying to say now here?
Boleh, madam.
Okay, ya, mesti kena opposite. Lepas tu dia dapat cancel. So this one you fill in the blank. The dipole moment cancel out each other, and the resultant is equals to 0 because everything is cancel out now. Cancel out mu is. Madam pun salah juga. Is equal to 0 because they cancel out. So in this case, XEF4 is a non-polar molecule. Okay. Ada soalan ke untuk XEF4? Non tetrafluoride. Okay, kita tengok pada structure yang lagi complicated. Complicated ke? Okay. Bf3. Bf bond, is it polar, non-polar? Bf bond, polar, non-polar? Hello? 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 Anybody home?
Polar.
Polar. Lukiskan awak punya arrow. Hadap ke fluorine, fluorine, fluorine. So Bf bond are polar bond. The shape is
Asymmetrical.
Asymmetrical.
okay. This is why madam said it is complicated, yeah. Okay, Bf3 is symmetrical. Okay, sebab tadi Hazim tanya kena tengok X and Y axis, sebenarnya tak juga. Kita kena tengok all the direction. So if you imagine, yang ini nanti nanti ada orang marah, madam sekejap cakap macam ni, sekejap cakap macam tu. Tapi dia apply kepada molekul yang berbeza ya sayang. Okay, so for this trigonal planar structure, okay, trigonal planar, you have to be aware. Kita tengok symmetrical dia macam ni. Okay. Or we look the symmetrical like this. Or we look the symmetrical like this. So all of the directions over here give you a symmetrical shape. Satu lagi contoh madam boleh tunjuk dekat sini adalah, if you look at the camera over here, can you see here? Look at the camera side, ya?
Yes.
Ataupun madam pin, boleh pin tak dekat sini? Cannot. you hold on ya. I try to stop sharing. And then dekat sini, Madam macam nak pinkan dekat sini
Tak apa,
Ya,
kita
main
orang
lah.
boleh pin.
You
So we
pin.
can actually pin.
You see my directions over here. I'm using the pen over here. Can you see my pen?
Can.
Yes, madam.
Okay.
Yes,
So
madam.
imagine this one is your Bf3. Each of them is the Bf bond. Macam tak nampak kejap ya. Okay, so I'm clearing up my background. Right? You see, look out here. So if imagine in the center is my boron, and then the sideway is your chlorine. So each of them looking like so I'm pulling the pen, pulling this one, pulling this one, pulling this one. So that means all of them have the equal strength. So kalau saya tarik sini, tak nampak ke saya?
Teacher dia tunjuk apa tu?
Dekat kamera.
Ni korang nak kena pin.
Personal
Nak kena
account.
pin Madam punya ni.
apa-apa.
Tengok pada kamera, Madam tak share screen sebab bukan tunjuk dekat screen, tunjuk dekat kamera. Can you see it?
Pun tak nampak.
Boleh nampak tak?
Kena cari
Ni pergi dekat bahagian yang kamera
Boleh,
Madam
madam.
buka. Betul pergi pin.
You tekan Madam punya screen.
Ni tak nampak apa-apa.
Ke selama ni awak tak nampak Madam?
Nampak.
Nampak. Madam ada dua account. Satu untuk Madam share screen, satu untuk kamera.
Okey, boleh nampak.
Them are using phone, so it's quite difficult to locate your view. But for laptop and PC, whatever, it's quite easier. So that's that.
Okay, tak apalah Madam tunjuk sekejap saja Nanti Madam cuba cari ada benda lain untuk Madam tunjuk example tak. Okay, untuk BF3 for whatever structures that you have trigonal planar. Okay, so imagine in the center I type a person. Let's say Hazim dekat tengah. Hazim sitting in the center. And then saya gulungkan Hazim, lepas tu saya ambil 3 tali. So one of it, so let's say Su holding over here. And then Irfan holding here. And then another one helper, Aiman holding here. Okay, so 3 of them using the equal strength. Tarik sini, tarik sini, tarik sini. Adakah Hazim akan bergerak?
Azim mati teacher.
Mati. Tak, ini cuma contoh saja
Sana
kita
tarik, sini tarik.
Okay, whatever directions I turn around, Hazim tengah-tengah Irfan tarik, Aiman tarik, Su tarik. Sama strength.
Tak, dia tak bergerak.
Hazim tak gerak kan?
Dia tak bergerak.
So kalau tak gerak, maksudnya resultant dipole moment dia kosong. You get me?
Equal to zero.
Faham Faham
Yes.
Okay, Madam tukar contoh Okay, so same. I have tukar jadi lagi pendek Ada apa benda yang lagi pendek dah. Okay, tak apa. Okay, so next let's say tak apalah. Madam tukar satu pen dengan highlighter. So let's say contoh dekat sini. Now, still the same as trigonal planar. Okay, sekarang Madam tukar Irfan dengan Fairuz, for example. Okay, tukar dekat sini. So Fairuz perempuan kan, dia punya magnitude ataupun dia punya kekuatan lemah sikit. So Hazim still in the middle. Now dia tali, Su tarik. Siapa tadi? Aiman tarik dengan Fairuz tarik. So rasanya Hazim bergerak ke mana?
Towards the
Bergerak ke
Towards the boys, isn't it?
Yeah.
Sebab boys punya lagi kuat kan. So Hazim pergi sini dah. Betul? Dia akan gerak. So maksudnya resultant moment, yes, there will be values. Did you see it?
Yes, madam.
Yes, madam.
Yes, madam.
So awak boleh guna contoh. Ingat tengoklah siapa yang awak bukan siapa yang awak nak locate dia dekat tengah. Let's say madam kat tengah. Awak nak gulung madam, nak tarik ke sana sini sana. Okay. So imagine madam gerak ke tak? Okay, so this is one of the analogy for you to determine whether this molecule having a zero resultant dipole moment or there's a value for the dipole moment. Okay, let's just come back to the examples over here. Yeah, I'm going to share back the screen. Okay, can you see my screen now? We go back to the one notch, yeah?
Yes.
Okay.
No, madam. Hold on, let me try. Alright, now I can.
Okay, so madam have already back to one knots, yeah? And then we go back to our example Bf3. So the shape over here is symmetrical. So dekat sini agak susah sikit untuk symmetrical ke asymmetrical. Awak kena tengok pada structure dan juga cuba tengok pada semua direction. Okay. And then we continue. The dipole moment, is it cancel out or doesn't cancel out? Do not cancel out.
Cancel out.
Cancel out. So sebab mana letak space dekat sini, so can cancel out each other. Okay, can cancel out or cannot cancel out. You boleh cuba buat ayat lah. Okay, do not cancel out or can cancel out. Okay, so the resultant dipole moment over here will be equals to 0 sebab Hazin tak gerak. So Bf3 is a non-polar molecule. Is everyone good over here?
Yes.
Okay.
Madam,
Yes.
so
Yep.
in order for us to know that either it is asymmetrical or not, we just need to look it at every angle possible. Am I right?
For now, I say yes for you lah, because it depends on the structure also. For now, I say
alright.
yes, but not always, not always, I say yes for now. Okay, right. What else I want to say? Okay, untuk polarity ni, madam faham dia susah sebab setiap tahun memang ada masalah. And then you need to understand this one because later in 4.4 we will use back this polarity concept. Okay, and then the next is last example over here is Bf2Br. Same thing, it is still trigonal planar, tapi macam tadilah Ilvan dengan Su tarik ke sebelah, lepas tu siapa-siapa lagi tarik ke sebelah dekat sini. Okay, so we try to look at polarity first, bond polarity. So Bf bond dekat sini, dia ada polar arrow. Dekat sini Bf bond pun sama juga polar arrow. How about BBr bond? What should we write?
Shorter.
What shorter? Why shorter?
Because
Fluorine is more electronegative.
Bromine is less electronegative. So the BBr bond will be less polar.
Polar.
So let's fill in the bond, the blank. So this, both of it is polar, but the Bf bond is more polar than the BBr bond due to fluorine is more electronegative than bromine. Dekat sini boleh tulis jugalah dia adalah asymmetrical sebab salah satu bond dia berbeza. Okay, so in this case, because it's not all the same, therefore the dipole moment do not cancel out each other. So maksudnya dia punya resultant akan hadap ke salah satu direction. So this resultant dipole moment is not equals to 0 and therefore it is, salah lagi. Dia adalah polar molecule. So when mu is not equals to 0, it is a polar molecule. Okay, is everyone good with this?
Yes.
Okay.
Madam,
Yep.
so for the template of which we need to write the Lewis structure, molecular geometry and such, the earlier ones. For the polarities section.
Okay, madam show, yeah? Madam show.
Oh, alright.
Wait, madam show one of the example. Why cannot? Hey. Okay. Hold on, yeah. Okay, we go back to the example just now. Say we want the example for H2O. Just now we have done one H2O, right? So in the last column over here, you only need to tell me whether this resultant dipole moment is equal 0 or not equals to 0. And then write whether it is a polar molecule or non-polar molecule. That's it. You don't have to do a full explanation. Tapi hanya kena tahulah sama ada dia adalah polar, non-polar atau depends kepada dia punya resultant dipole moment. Boleh ke? Is that okay, everyone?
Noted, madam.
Dalam last column, tak payah explanation panjang lah. Madam hanya nak short kind of like the conclusion. Resultant dia macam mana, lepas tu dia polar ataupun non-polar. Tapi yang awal-awal awak kena tahulah sama ada dia dapat cancel ke, tak dapat cancel ke. Okay. And then one more thing. I want you to try to put down the polar arrow. Tapi guna warna lain lah. Contoh awak lukis dalam pensel kan. Okay. Ataupun dalam black pen, blue pen. You're using a different color pen to put the polar arrow. For example, I'm using H2O. And then this will be my polar arrow. Besarnya. Kind of like this lah, using a different color. Okay, polar arrow. Polar arrow. Tunjuk dekat sini. So untuk electron group 2, 3, and 4, that one you have already do. You just top up only. Okay, so let's just try the next example. Okay, wait. So we try the example over here. So question number 1, consider the species NH2 negative and NH3 molecule. First, determine the molecular geometry. Second, deduce the polarity. And then number 3, explain the differences in the bond angle inside both of this structure. Okay, so Lewis structure for NH2 negative. Again, you have to repeat all over again. What's the total electron? So over here we have 5, 2 hydrogen, we have 2. The negative charge give you an extra electron. So total we have 8. Okay, so in this case, Lewis structures, kalau awak Lewis structure dengan molecular geometry, bila awak sudah faham macam mana nak lukis shape, satu structure cukup. So maksudnya Lewis structure awak masukkan shape terus. When you have already comfortable, you have already familiar, Lewis structures 1 is enough. Okay, 1 is enough. That means you only got the Lewis structure with shape. Okay, so ini adalah structure untuk awak punya NH2 negative. Always check back lah, the total electron inside the structure and the calculation should be the same. 2, 4, 6, 8 in the structure, total value also the same. Similar to our NH3 calculation, you have to show it yourself lah. So the structures of NH3 like this. Ini contoh method terus letak shape. Kalau awak belum familiar lagi, awak boleh lukis biasa. Without the shape. Okay. So electron group for NH2 negative, how is it? How many electron group for NH2 negative?
4.
What is the combination?
2 lone pair, 2 bonding pair.
2 bonding pair, 2 lone pair. Okay. How about NH3?
Madam,
sorry?
Can we actually write it short form, just BP, LP, or do we need to fully write the whole designation?
Because now you the final exam is in Google Form. Okay, so no problem. You just need to know about BP, LP. But for written exam, need to be full. Sebab awak tak ada written exam, so awak boleh shortcut lah, tak ada masalah. Tapi dalam full exam, written exam, kena tulis punya, tak boleh shortcut. Cuma dekat sini madam bagi shortcut untuk mempercepatkan. Okay, ya?
Alright, noted, madam.
Alright, hey, NH3 electron group 4. What is the combination?
1 lone
3
pair,
bonding
3
pair, 3 lone pair, 1
Very
lone
good.
pair.
3 bonding pair, 1 lone pair. Electron group arrangement untuk kedua-dua adalah sama, Yaitu, what is the electron group arrangement? For electron group
Tetrahedral.
tetrahedral. Ingat electron group arrangement dia depends kepada electron group. Nombor yang 4 ke, 3 ke, 5 ke. Okay, so NH2 negative and NH3 they have the same electron group arrangement. Molecular geometry. NH2 negative give you the shape of a, dia bagi shape apa? A V shape. Well done. And together we put the bond angle later on the bottom, yeah? Okay, how about NH3?
Trigonal Bipyramidal.
Yes, pyramidal. Satu pyramidal dengan base dia triangle. Kita panggil dia sebagai trigonal pyramidal. Okay, so dekat kolom sini kita applykan molecular polarity. Okay, so when you want to draw molecular polarity, make sure you draw the polar arrow. So kita hadap ke hydrogen ke nitrogen? Which one is more electronegative?
Nitrogen.
Nitrogen. Okay, so kita lukislah nitrogen kat sini. Okay, therefore we can see.
We need to draw the arrow at the molecular geometry.
Yes. Okay, draw the polar arrow on top of your molecular shape. Bukan atas Lewis structure sebab Lewis structure tak tunjuk shape. Kita tak dapat nak tunjuk polarity. Okay. So over here you can see they do not cancel out each other. Therefore you have a resultant dipole moment. So it's not equals to 0. Therefore NH2 negative is a polar molecule. Okay, how about NH3? Kita sama juga tunjuk ke arah nitrogen. So resultant masih sama. Sebab semua push ke sama direction, dia tak dapat nak cancel. So maka kedua-dua structure ni adalah polar molecule. Did you get it?
Yes.
Okay, right. So we continue Vesper theory. So coming to your repulsion. Okay, so for NH2 negative, what will be your Vesper theory say?
2 lone pair, and then 2 bond pair.
Kena tahu kita kan ada 3 kategori. Dalam ORB-nya NH2 negative ada 2 lone pair. So dia mesti ada repulsion antara 2 lone pair ni. Okay, so repulsions between lone pair is greater than lone pair bonding pair and is greater than bonding pair. Sebab dalam NH2 negative kita ada ketiga-tiga repulsion. Ketiga-tiga jenis repulsion. And then tell me about NH3. How will be the repulsion?
Lone pair, bonding pair.
Yes, and?
Bonding pair, bonding pair.
Yes, there's only 2 types because you only got 1 lone pair. So repulsions between lone pair bonding pair is greater than bonding pair. This is Vesper theory. Okay.
Teacher,
Yeah.
aku tak faham kenapa yang kiri tu lone pair, yang kanan tu lone pair, bond pair.
Okay, so I'm using a highlighter to show you. If you look at NH2 negative, kan dia ada 2 lone pair. So maksudnya antara 2 lone pair ini, dia akan repel. Jadi dia ada lone pair repulsion. Dan kenapa untuk NH3 dia tak ada? Dia hanya satu. Dia nak repel dengan siapa? Dia hanya boleh repel antara lone pair dengan bonding pair. Bonding pair memang semua molekul ada.
Okay, faham.
Okay, very good. Okay, bond angle for this one, yeah. Just now, madam, tell you that our H2O has a bond angle of 104.5. Okay, because you have 2 bonding pair, 2 lone pair. So over here, NH2 negative is similar like H2O. So we will write down 104.5 degree. Tapi kalau awak tulis kurang daripada 109.5, betul. Betul juga. Tapi untuk kedua-dua kalau awak tulis sama, jadi kita tak dapat nak bezakan. So in this case, because our question number 3 asks about bond angle, what is the difference? So we have to write the value. So NH2 negative similar like H2O, so it will have about the same bond angle, 104.5. Whereas for NH3, it's a fixed value, 107.3 degree. Okay, so the last questions over here, question number 3, we go back to the questions again. Using Vesper theory, we have already described just now. Okay, explain the differences of H and H angle in both of these species. So kita tulislah dekat sini jawapan dia, explanation. Bond angle of NH3, which is 104.5 degree, compared to 107.3, is it smaller or bigger? Comparing the values?
Smaller.
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 And this is because the repulsions between, kita nak compare apa? Compare yang obvious punya. Apa yang berbeza antara dua species ni?
Lone pair.
Ya, lone pair repulsion kan? Sebab dalam NH3, kita tak ada lone pair repulsion. Okay, so over here, I write that NH2 negative is greater than that. Greater than lone pair bonding pair repulsion. Nak tulis shortcut boleh lah. Ini masalah kenapa madam guna shortcut nak tulis lama sikit. Tapi kalau awak faham boleh shortcut dalam nota. Okay, so lone pair repulsion is greater than lone pair bonding pair repulsion.
Madam,
Yes?
saya tak faham yang bond angle tu. Memang kena letak 104.5 degree ke? Atau dia boleh choose between tu?
Dia kalau, okay, madam buat a general idea. Kalau untuk structure yang tentu, untuk yang spesifik untuk H2O, memang ini kena ikut. Okay, this value should be followed. But NH3 negative, kalau dia individu soalan saja. Individu soalan saja. Awak boleh tulis kurang daripada 109.5. Tapi sekarang dekat sini dia nak kita compare. So kita terpaksalah bagi satu value. Value 104.5 sebab structure NH2 negatif ni dia lebih kurang sama macam kita punya H2O, shape dia. So dia punya repulsion. Dia punya repulsion adalah lagi kuat. So macam mana nak? Okay, back to the cameras again. Kalau untuk NH2 negatif kan, repulsion untuk lone pair dia besar, so dia punya bond angle dia akan squish. So awak akan nampak dia lagi kecil daripada 109.5. Compared to NH3, sebab dia hanya lone pair bonding pair repulsion. So walaupun dia kurang daripada 109.5, tapi dia kurang sikit saja, 107. Is that okay for you?
So memang dia fix lah ambil nilai tu.
Dekat sini madam bagi fix sebab kita nak buat comparison. Tapi kalau dia individu NH2 negatif, awak tulis negatif, kurang daripada 109.5, okay.
Faham.
Alright. So untuk soalan kedua ini, untuk PCL3, PCL5, madam nak awak buat ya. So yang ini submit dekat GC. Soalan ni saja dalam GC. Okay. Madam tak bagi jawapan kan dalam awak punya nota? Tak ada kan?
Tak ada.
We were wishing for that.
Tak ada.
Yeah, GC only question 2. And then for exercise 2 over here also on your own, for your own practice. So you see question number 1, you need to predict the shape, the bond angle, there's 6 structure. And then for question number 2, get similar questions. Compare the HOH angle in water and also H3O+. Sama macam tadi. Okay, lepas tu soalan 3, determine polarity. So, sama jugalah awak kena keluarkan shape. Baru boleh tentukan polarity. Polarity dekat sini maksudnya untuk molekul, bukan untuk bond. Okay, and then last question is to combine everything inside a questions. So dia bagi scenario dan dia suruh awak describe geometry. Geometry maksudnya shape ya. Untuk ion. So maksudnya dia minta shape untuk XeF3 positive, SbF6 negative and then XeF5 positive. Dia nak ion sahaja. Okay, so ini untuk exercise sendiri Madam akan bagi jawapan kemudian. Untuk soalan yang hari itu Madam suruh awak buat try sendiri kan 1 hingga 5. Jawapan Madam sudah attach dekat OneNote. Video akan ikut kemudian lah. Kalau sesiapa nak rujuk video boleh, nak rujuk terus jawapan pun boleh. Okay. Is there any questions before we moving to 4.3?
Madam, for the
Yes.
polarity and explanation, we need to write in full.
Which
Or
one?
just,
For which one? For this
for
table.
the people.
The table here.
Yeah.
Okay, the table here no need. You just need to write down. Just now, Madam show the example. You just need to write down the mu and also polar or non-polar.
Okay. And then
Because this table later is for your revision, so we make a short notes lah. Okay.
And Madam, my next question is about the molecular geometry. So it only depends on the Vesper theory lah. So it has nothing to do with the electronegativity of the atoms.
The shape, yeah.
Yeah.
Yes.
Means that H2O has the same shape as NH2 negative ion.
Yes, it will be the same shape. Depends on how many electron groups, what is the combination, and also your Vesper theory.
Okay. Thank you, Madam.
Okay, very good. Ada soalan lagi? Okay, kalau tak ada soalan, kita move on 4.3, lagi challenge. Rasanya 4.1, 4.2, okay lagi tak? 4.1, 4.2, is everyone okay? Sebab 4.3 is another level higher.
Boleh lah.
Okay, good.
Kita proceed Take the challenge. 4.3, orbital overlap and also hybridization. So in this subtopic, we are going to draw and describe formations of your sigma and also pi bond by using overlapping of orbitals. So we come back to orbitals, SPD. Okay, and then describe the formations of hybrid orbitals of the center. And we got sp, sp2 until sp3d2. Okay, using appropriate example. Don't worry. Madam will show you. And then C, illustrate hybridizations of the central atom and the overlapping of the molecule. So dekat sini kita ada banyak lukisan. Satu soalan, satu muka surat. One question, one page. Okay.
Is that big?
Madam will show you an example. Don't worry. Okay, so we start off with the theory first. Before this, we learned about Vesper theory. So now in this chapter, you have your second theory, which is valence bond theory. Okay, in this theory, it says that a covalent bond is formed between two atoms by overlapping between the half valence atomic orbital. Okay, overlapping between the half-filled valence atomic orbital of each atom containing 1 ampere electron. So, sebab dia adalah covalent bond. Jangan lupa covalent bond. Kalau saya ada species A, species B, each of them will donate 1 electron for sharing. A donate 1, B donate 1, mereka buat covalent bond. Okay, lepas tu kita kena tahu dia punya overlapping. So this is your valence bond theory. So macam mana awak look daripada first subtopic until now, you have seen valence bond theory is sharing between two unpaired electrons. Okay. So we start with the easier one, direct orbitals overlap. What to say direct orbitals? That means we use the original orbitals. Yang awak belajar kan? S orbital, P orbital, D orbital kita tak pakai sebab D ke atas dia adalah lagi complicated. So kita hanya fokus kat S dengan P sahaja. Okay, so the direct orbital overlap means there is an overlapping between the pure S and pure P orbitals to form this covalent bond. And then they usually is for simple molecules or ion. Okay, simple molecules or ion can use the direct orbitals overlap. So for example, over here we got H2, we got HF, O2, N2, OH minus. They are considered as simple molecule or ions. Okay, so before Madam showing you example, you need to know there is two modes of overlapping. So first mode is what we call end-to-end overlapping. End-to-end. Okay? And when you have end-to-end overlapping, you are forming a sigma bond. So we are using the symbol like this, sigma. Okay, please learn about how to draw the sigma bond. Yeah, sigma bond, end-to-end bonding, end-to-end overlapping. So this sigma bond is for all single bonds. And usually all bonds also consider, it's like a basic. Semua bonds, dia akan ada sigma. Single bond ada, double bond ada, triple bond pun ada. It's a basic bond for all. Tapi kita cakap semua single bond, memang dia satu bond saja, that is sigma. Single sigma. Okay. And then this sigma bond is free rotated. It can have free rotation. So contoh tengok pada kamera madam. My red pen's coming back over here. Can you see my red pen?
Yes.
Yes.
Okay, so ini adalah single bond. Atom on the right and left. So dekat sini atom saya boleh pusing. Madam pusing macam ni. So ini maksudnya free rotation. So that means it can rotate it on its own. This is free rotation. Okay, but when we come into pi bond, okay, pi bond is overlapping side by side. Sebelah, dia bukan end to end. Kena asingkan end to end overlapping and also side to side overlapping. Okay, so side by side overlapping. Madam tunjuk contoh lah. Okay, kalau end to end tadi contoh saya ada one S orbital. Dekat sini pun 1s orbital. Ini end to end. Tapi satu bulatan tak nampak end dia kat mana. So tak apa. Kita guna P orbital pula. So let's say Madam pakai 2P. Let's say 2P. End to end means this one. Dekat sini overlap. Ini 2P, ini 2P. So this one is considered our end to end. Are you clear about that? Boleh ke end to end? Yuk, tak nampak. Are you okay? End-to-end overlapping. Ataupun antara 1S dengan 2P. Ini end-to-end overlapping. Okay, but when we talk about pi bond, dia adalah side by side. So macam mana side by side? Side by side hanya boleh P orbital ya. Okay, P orbital. Madam catat dekat sini, awak pun catat juga. Okay, side by side maksudnya kita kena buat macam ini. Side by side overlapping. So ini contoh side by side overlapping untuk kita punya pi bond. Boleh catat sikit lah atas awak punya nota. Side by side, end to end overlapping. Okay, so for this pi bond, side-by-side overlapping is for double bond and triple bonds. Okay, and then it has restricted rotation. So back to your camera. Look at Madam's camera. So sekarang contoh Madam ada double bond. Can you see there's a red pen and a black
Yes,
pen?
madam.
Okay.
Yes.
Okay, kenapa kita cakap restricted rotation? I twist it, tak dapat pusing. So cannot rotate. Cannot rotate, it's restricted rotation. Kalau bandingkan dengan sigma bond, single bond, rotating very easy. So this is free rotation, single bond, but when you have double bond or triple bond, you cannot twist it. So that is what we say about restricted rotation. Are you okay?
Yes.
Yes.
Yes, madam.
Okay.
Noted.
So over here, multiple bond, double or triple, has one sigma and one or two pi bond. So this one we will show and look at the next example. Okay, so over here. Okay, so valence bond theory, we look at sigma first for the simple one. Let's say H2. We know hydrogen having one electron in one s orbital. So untuk dua-dua hydrogen adalah sama. So kita tengok dia punya Lewis structure ya. H over here. Sebab kalau Lewis structure sama jugalah macam apa yang awak buat sebelum ni. HH dia punya Lewis structure nampak macam ni. Okay. So one s orbital from your first hydrogen. Okay. It holding one electron. Ini untuk satu hydrogen. Okay. And then another hydrogen, your second hydrogen. Sorry, I made it drawing a little bit bigger lah. Over here. Another 1s. So this is coming from another hydrogen with another electron. Okay, so this is your sigma bond. So each of the hydrogen sharing one electron, and then they are making this sigma bond. So pi bond is formed by overlapping end-to-end between 1s orbitals of each atom. So kita guna balik original atomic orbital yang ada. Lukis sama-sama
Sigma bond ni sharing je lah dia punya key dia.
Ya, kita nak tunjukkan macam mana mereka sharekan elektron. You are now swimming deeper a little bit. Lewis structure kita tengok pada permukaan kan. Now you go into deeper. You want to see what is inside that bond. So kita sekarang tengok macam mana mereka sharekan bonding dalam covalent molecule. Okay. Second example for sigma. Sekarang kita combinekan H and F. So tengok pada Lewis structure dia. Mari tukar warna balik merah. Okay, so now your Lewis structure for HF look like this. 8 electrons altogether, 7 from fluorine, 1 for hydrogen. Okay, and then looking at the electronic configuration, hydrogen we are using 1s. Fluorine kita guna apa untuk buat overlapping? Kat mana ada single electron? Where do you have 1 ampere electron inside fluorine?
2p.
Nampak dekat sini 5 kan, maksimum 6. So kita tahu kita ambil 2p untuk buat end-to-end overlapping. Okay, so 1s orbital from our hydrogen, there's 1 electron there. And then for our fluorine, 2p, therefore we are using a dumbbell shape. I hope you still remember p orbital, it refers to dumbbell shape. Okay, so this is the 2p orbital of our fluorine. So fluorine mana letak kat tengah. Atau letak sini pun boleh lah. Okay. Kis balik Okay, so for our fluorine, there's another electrons over here. So over this bond, when you have the overlapping, this is your sigma bond. So this is overlapping between s and p orbital. So sigma bond is formed by overlapping end-to-end between 1s orbitals of hydrogen with 2p orbitals of fluorine. Is everyone good?
Yes.
Okay, remember yang dekat sini adalah direct overlap. Kita belum masuk hybridizations lagi. Dekat sini kita hanya guna balik apa yang sedia ada dalam atom awak. In the hydrogen, in the fluorine. Okay, next example is F2. Okay, we are using 2p for both fluorine to do overlapping. So this is your Lewis structure. Okay, so you don't need to think about the lone pair around the fluorine. Don't have to worry. You just focus on the bond formations. Focus on the sigma bond only. Okay, so first dumbbell, first 2p from the first fluorine, 1 electron. Okay, and the next fluorines come to do overlapping. So this is 2p of another fluorine atom. So in the middle is your sigma bond. So make sure madam tunjuk contoh overlapping dia mesti dekat last kali dekat sini saja. Madam tak nak nampak ada yang overlapping satu dekat sini. Ini salah ya. This is wrong. I need only a little bit end of the loop to do overlapping. Macam Olympic kan. Olympic kita pakai macam ni. Dia overlap dekat sini saja. Last sikit saja. Jangan masukkan semua orbital dalam overlapping. Okay. So, what do you need to fill in the blank? Overlapping end to end between?
2p orbital.
2p orbital of our fluorines atom. Okay. Sekarang kita nak masukkan pi bond. Okay. So we back to the last sentence madam mentioned. A multiple bond has 1 sigma bond and 1 or 2 pi bond. So look at the second, the bottom example when we're using the pi bond. Okay, so we start off with the Lewis structure of oxygen. Okay, dekat sini madam buat kat tepi untuk O2 Lewis structure dia. Okay. So O2, it has a Lewis structures looking like this. Okay. So remember, in a multiple bond, your first bond is always sigma bond. So atas awak punya Lewis structure, ada satu sigma, mesti ada satu sigma. Sigma exists in all the bond. Single, double, triple, all the bond having sigma. So untuk O2, the first line is your sigma bond. Then the remaining one is your pi bond. So line yang kedua dalam awak punya double bond adalah satu pi bond. Can you see over here? Maybe enlarge a little bit, yeah? So maksudnya betapa penting awak punya Lewis structures. You must get a correct Lewis structure. So oxygen has 1 sigma bond and 1 pi bond. So if you're looking at the electronic configuration, you can see over here. One of the unpaired electron from the first oxygen combining with the second unpaired electron of the second oxygens to make your sigma bond. Okay. And then another structures over here, another unpaired electron, okay, coming in to make your pi bond. So ini oksigen yang pertama, ini oksigen yang kedua. So mereka akan matchkan untuk buat overlapping side by side untuk end to end. Okay, so this is how we are going to draw the overlapping. So we start off with the end-to-end overlapping. Ini untuk oxygen, one of the 2p orbitals. Okay, oxygen 2p. So over here, we have another oxygen, also one of the 2p here. So dekat dalam sini ada 2 elektron. Mereka akan jadikan sigma bond. Do you get me? Can you follow?
Yes.
Yes,
Okay.
madam.
So kita isikan ayat dulu Sigma bond is formed by overlapping end to end between 2p orbital of each oxygen atom. Tapi 2p yang mana satu? Tak kisahlah awak isikan. Awak nak guna X ke, Y ke, Z ke, whatever. So you write down 2px. Because each of them, maybe this one is 2px, this one 2py, this one 2pz. So tak kisah awak ambil mana satu, X, Y, Z. You just label them only. It's just a label. So kita nak tunjukkan end to end, kita pakai salah satu p orbital. Okay, so now I change another color to show my side-by-side overlapping of another p orbital. Okay, so dekat center yang sama untuk oksigen yang pertama, kita ada lagi satu p. Let me remind you again, your p orbital, there's three, in the p subshell, we have three orbitals, which represent by -1, 0, +1. Along z-axis, y-axis, or x-axis. So dia mereka adalah perpendicular ya. So untuk oksigen yang pertama kita ada lagi satu 2p. So let's say saya nak ini sebagai 2py. Tadi ini madam label sebagai x Okay. Nak label y pun boleh, label z pun boleh. Okay. So the second oxygen also I'm using 2py. Okay, now in your first oxygen, here we have one electron. So, madam bulatkan dekat sini. Kita isikan dalam orbital dia. Untuk yang kedua, isi dekat kedua oksigen yang kedua. So, that means in each oxygen in the 2py orbital, they having each unpaired electron. So, now, side by side overlapping. Jauhnya macam mana kita nak overlap? Tak nampak. Tak apa. Kita gunakan curve arrow. Atas bawah kena link. Sebab dia adalah satu cycle. Atas bawah kena ada. Lepas tu, awak kena labelkan. Ini adalah kita punya pi bond. Okay. So, pi bond is formed by overlapping side by side between 2py orbital of each oxygen atom. Okay. So, end to end refer to sigma. Side by side refer to pi bond. So refer back to your Lewis structure. That's one sigma. There's one pi bond. So bila awak lukis overlapping, kena make sure awak punya bilangan pi dengan bilangan sigma sama dengan awak punya Lewis structure. Is that okay? Boleh ke semua orang?
Boleh.
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 Okay, kita tengok pada N2. N2 lagi complicated. Siapa ingat structure untuk N2? Lewis structure N2. Tak ada orang ingat. Structure N2 ada triple bond. Nah, practice balik awak punya what's it called, the Lewis structure starting from total valence electron. Okay, inside N2 there's a triple bond. No worries. You will have one sigma, definitely. And then the second line and the third line, that means you have another 2 pi bond. Okay, one sigma, 2 pi. Sebab dia triple bond, dia mesti ada 3 label. Okay, satu sigma dengan 2 pi.
Madam.
Yes.
So basically speaking, the first bond is always going to be the sigma bond.
Yes.
And the rest would be pi.
Yes, if you get extra, there will be a pi.
Alright.
Yeah. Okay, so we back to the electronic configuration. So the first bond is our sigma. Okay, how about the second bond?
Pi.
Pi. How about the third bond?
Pi.
Pi. So dekat sini madam warnakan sigma, pi and pi. So dia punya overlapping akan jadi lagi complicated daripada O2. So don't worry, you begin with the x orbital. X orbital pula. End to end overlapping your sigma. Okay, so ini untuk N, the first nitrogen. And then let's say I'm using this one as 2px. Ingat X, Y, Z dia sama energy. So tak kisah awak guna mana satu. Okay, so another nitrogen, another 2px. Okay, so over here, you are forming your sigma. So sigma bond is formed by overlapping end to end between 2px orbital of each nitrogen atoms. Is that okay? Boleh ke untuk sigma?
Boleh, madam.
Boleh, madam. Okay, so kita lukis lagi dua pi bond. So remember, pi bond side by side, that means you have another two overlapping. So saya slanting a little bit lah. Okay, let's say over here I have my, dia mesti kena parallel. Apa yang awak buat? Dia mesti kena parallel. Make sure the two bond, the two dumbbell shape. Okay, it must be parallel. So let's say I make this one as my 2py. This one also need to be 2py, parallel. So one of the electron each. Okay, and then these two will overlap. Tak payah arrow pun tak apa Kalau awak lukis line saja pun boleh. How am I going to rub off? Okay, kalau tak ada arrow macam ni pun okay. So let's say tak ada arrow Madam tunjuk ni. Okay, so this one is your pi bond. First pi. And then we will have a second pi. Okay, a second pi, that means another direction lah. But make sure they are parallel. Dekat sini untuk yang biru, warna biru dekat sini adalah kita punya 2pz. So Madam letak dekat sini 2pz for the blue color one. And each of them having one single electron. So now when you draw already the dumbbell shape, you need to label. So bila awak lukis satu pasangan, terus label. Jangan tunggu semua baru awak start label. Nanti awak akan salah label. You will see, saya lukis apa ni? So when you draw already one pair, you straight away labeling. So for this blue, up and down, atas complicated kan? So kita labelkan pi dekat tempat kosong. Tapi dekatlah dengan awak bina side by side overlapping of the second pi. So in your sentence over here, there's two pi bonds are formed. Yes?
During the exams, do we need to actually do this diagram?
In your written exam, yes. So awak kena bersyukur sebab sekarang awak tak ada written exam.
Hurrah, hooray.
But you have to recognize the diagram. Diagram mesti kena ingat lah. Mana tahu dia keluar diagram, suruh awak pilih mana satu yang betul.
Madam, so if we were to actually need to draw the diagram, do we need to use different colors or is it acceptable if we just use one color only?
To use one color, that's okay. Madam pakai color warna-warni supaya awak nampak macam mana Madam lukis.
Oh, alright, noted.
Kalau untuk awak punya nota, awak nak guna warna-warni untuk nota reference sendiri, you're very welcome. Okay, so for the explanation, two pi bonds are formed by overlapping side by side between 2py and 2pz orbital of each atoms. So ini tak cukup tempat so awak labelkan 2py, 2pz. Okay, so Madam bagi masa yang awak catat dulu.
Medium.
Yes.
Dia punya line tu kalau arrow kena memang kena apa?
Opposite side.
No. I mean kenakan dekat dia punya 2p tu ke?
Tak faham. Macam mana Arrow kena dengan 2p?
Kena sambungkan ke arrow tu?
Kena sambung?
Aku tak tahu macam nak cakap.
The lines of the arrow, we need to contact between the two p's.
Yeah. To show that they are overlapping. Okay, to show that they are overlapping. I don't know whether I'm answering your questions or not, but try to. Okay.
Madam, tadi
Connect
madam
lah.
ada cakap 2PY, 2PX tu dia mana-mana pun tak apa kan? Mana-mana satu pun
X,
tak
Y,
apa.
Z tak apa. Kalau awak nak guna ini Y, yang ini X dengan Z tak kisah sebab sama energy.
As long as we can differentiate, right?
Yeah, as long as you can differentiate them. Correct. But bear in mind, the example Madam show over here is only for direct overlapping between atomic orbital. Bila Madam cakap atomic orbital, maksudnya kita tak buat apa-apa dengan orbital dia. Kita masih guna original orbital yang sedia ada untuk atom tersebut.
Wait, there's more?
There's more, yes.
Oh dear.
So yang ini simple a little bit. We have much more complicated one. Okay, so this one, have you finished copying?
Done, but I have one question. Can we do?
Yes.
Yang arrow dalam 2P tu kena buat juga ke?
Ya, arrow dalam 2P melambangkan awak punya elektron. Dekat sini kan 2P ada elektron kan. Kita hanya pindah dia masuk dalam orbital lukisan kita.
Okay, faham.
Okay, electron represent by the arrows ya. Okay, so kita cuba sikit untuk exercise. So the complicated one next week lah. Exercise number 1, identify the number of sigma and pi bond content in the molecule above. So maybe enlarge a little bit. So kita buat sama-sama tolong kirakan berapa sigma bond yang kita ada. Kita ada bagi masa. Sigma bond ada berapa?
11.
11.
11 bonds.
Pi bond?
There's 3.
3. Kita check Okay, untuk sigma, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well done. Okay, whereas for our pi bond, you remember the multiple bond, the second onwards we consider as the pi bond. We have 1, 2, 3. Well done, you. Okay, so 3 for 11 sigma and 3 pi bond. Now, of course lah, untuk dia punya overlapping, madam tak suruh untuk awak buat structure macam ni. Tak ada. Dia simple sikit lah untuk buat overlapping. Okay. Lepas tu, untuk exercise yang kedua, by using valence bond theory, explain the bonding, show the bond formations by the overlapping, exactly like what we did above. Okay, so you need to show your OH minus and also Br2. Okay, so that means you need to give me Lewis structure. You need to have electronic configuration. You need to have overlapping. And you need to have explanation. So dekat sini, madam tunjuk contoh untuk OH minus. As your last example, untuk Br2, similar like F2, you can do it on your own. Okay, so madam tunjuk untuk OH minus. Start all over again for your Lewis structure. Okay, so we have oxygen 6, hydrogen 1, plus 1 over here, we had 8 valence electron. Okay, so because hydrogen is duplet, so we cannot put electrons onto your hydrogen. So this is your Lewis structure for OH minus. Okay, and there's only one sigma bond. Okay, and then we have our oxygens, 1s2, 2s2, 2p. 2p. For sure, right? 2p.
2p2.
2p2? Oxygen?
2p3.
2p3. P2p. You want
Salah, madam salah.
2p4.
Because 1s,
2p4, 2p5.
2s2. So now 2p2.
2p4.
Wait.
2p4.
What?
Ah.
Oh, I mistaken. Alright, sorry.
2p4 betul. Kelakar. Sekejap Ini bukan 2p4 Sebab kita kena tengok formal charge. Tengok madam pun sudah ni dah. 2 jam imagine kalau madam nak ajar 4 jam macam mana. Tapi kesianlah you 1 hari kan. Dengar macam-macam. Okay, kita try untuk formal charge. Okay, oksigen. Formal charge dia berapa? 6 minus 6 dot minus 1 line equals to
-1.
-1. So that means oxygen accepting 1 extra electron. Okay, so untuk oksigen memang dia 2p4. Tapi kita bukan guna sorry 2p4 ini original. Tapi kita bukan guna oksigen sahaja untuk overlapping. Kita pakai O-. Sebenarnya yang overall charge ini terletak pada oksigen. That's why you learn about calculations for formal charge. So for O negative, okay, so kita ada 1s2, 2s2, 2p5. Okay, kenapalah madam letak soalan ni? Soalan ni dia come last tapi sebab dia wujud dekat sini, so madam ajak terus lah.
So we need to also mention the
that's why I can't remember who asking should we calculate formal charge for every questions. That is just in case if you calculate O is 0, then no problem, you proceed. But it is dangerous if you have the atom with a non-zero value formal charge.
Alright.
So dia berlaku dekat sini lah. So madam tunjuk dulu kita ambil O negatif untuk guna dia punya 2p orbital. Kita overlap dengan 1s hydrogen. Okay, so untuk overlapping kita start dengan oxygen. Oxygen we use the 2p. So since we only using 1p, so you don't have to label X or Y or Z because only 1. Just now in more than 1, then we label X, Y, Z. Okay, lepas tu untuk hydrogen pula kita ada 1s. So this one is your 1s, hydrogen, another electron. So, belum lagi. Sebab dia ada negative charge over here, so over here I put a O minus lah. Okay, as a label. Then the label kan last kali adalah dia punya sigma bond. So instead of O, we put a O negative. But sorry, this question it should come last. But madam put it here, so madam teach you straight away. Okay, so this is the extra one over here is your O negative, where we need to calculate for the formal charge. Madam will show a few more example at the end of the hybridization subtopic to reconfirm back the structure. So bagaimana ataupun dekat bila kita kena kira formal charge, kita kena carikan sama ada dia O ke O negatif ke untuk gunakan overlapping. But in this case, I just want you to know that direct overlapping between 2p from oxygen, 1s from hydrogen. And this is end-to-end overlapping. Is everyone okay over here with the overlapping one?
Yes.
Okay, untuk BR2 awak cubalah. So untuk coming lesson on Sunday, we will going into a much more difficult one. And you need to prepare for that. Okay, so before we finish, madam didn't do the quizzy already because quite a number of you didn't try it. That means madam cannot record attendance. Ada yang boleh access, ada yang tak boleh access dan macam-macam benda lah berlaku. So from this lesson onwards, we will go back to Google Form, which is a little bit more boring. Okay, so scan this QR code. So you will need to fill in the Google form. There is 4 questions. So from there, madam can assess who is with me in this Google Classroom. Those who are not with me, what is the reason? Why are you not attending? And I need to check all of this. Sebab madam nak kena isi awak punya attendance. Dan madam bagi tahu siap-siap dulu Mungkin ada yang tak ada dekat sini, tapi untuk the rest who are inside here, for every of your classes, if you skip the class more than 3 times, you are going to receive warning letter from lecturers. So warning letter kalau lebih daripada 3 ataupun 4 kali, warning letter yang pertama akan bagi kepada pelajar, akan bagi kepada awak punya parents. Okay? Lepas tu, warning yang kedua, kalau awak skip ataupun ponteng tanpa apa reason, sama ada berturut-turut ataupun alternate or whatever, more than 6 and above, surat amaran yang kedua akan diberikan kepada pelajar dan juga parents. If more than 9 times, surat amaran akan keluar daripada HAP. If beyond that, you're going to punish Ada denda ke, ada saman ke, 500. If more serious than that, you are going to kick out from the college. Am I making myself clear now?
Yes, madam. I'm just.
Okay.
Can I ask about the QR code because I've scanned.
Tak boleh scan
And may I show you what I got?
Yes.
Right. So now it's correct, right? Because I've got this after I scan it.
Yes.
So that's all?
So you have a few pages right after you fill in your name, your practicums, and then 4 question assessment, and then after that feedback, and then submit.
So here, previous and next.
Yes, you go next, and then until the last one, you're going to submit. So make sure you press the submit button.
All right. Why don't you use
link?
Alright.
Madam akan bagi link, cuma madam risaulah kalau madam hantar link dalam awak punya Telegram, nanti orang yang tak masuk dia scan juga. So madam tak dapat nak detect. This is the problem why madam doing this one. But hold on Madam bagi dalam Meet dekat sini. Where is it?
Do we need to scan? Because I already scanned and.
Yeah, you can either use scan or using the link that madam post here.
The problem is that when I scan just now, I only get ads only. So when I press next, different ad, no change of the page. I'm not sure it's either my.
Yang lain sudah cuba belum?
Boleh.
Okay, madam open the page. Those who are using this one, the date is today. So let's say today, and then practical, let's say MS7. Okay, let's say I choose the name for me, and then Max over here, you can see. Okay, there's 4 questions. What should we choose? Untuk last question dekat sini, bonus lah. So, madam belum ajar lagi. Tapi awak boleh refer nota macam mana kita nak tentukan hybridization. Tapi madam tak tengok lah soalan ni sebab madam belum ajar. Okay, lepas tu. Okay. And then after that, when you have already done it, you need to click submit. But all of this is required questions lah, so you have to choose the answer. Last sekali ada jugalah awak punya feedback. If you have any feedback, madam terlalu cepat, terlalu lambat, nak exercise banyak. Exercise jangan minta banyak sudah banyak enough. Kalau siapa complete lagi exercise,
So from now on, you just going to give us the link for our attendance, right?
I will see how lah.
Alright.
So madam tak dapat nak detect siapa yang tak present.
Because sometimes I use my phone, so